Okay, so we're trying to work on some camera controls. So, nice camera. Friday, video number 158. So, we're adding this nice cam sub-library. And the reason for that is, well, let's just go into it, right? So, if we're over here, and we go into... I gotta suspend my hotkeys here to get this working. So if we go in here, do P for pattern, and then go over here to one of our patterns, right? And we try to zoom in, right? We're going really slow, we're going really slow, we're going really slow, we're going really slow, 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 and then, whoa, oh my god, really fast. Like, right here is, like, really fast. That's not actually true, right? What's happening is that we're going at a linear zoom the whole entire time. However, as we get further and further away, we see more and more stuff, and then it appears to move slower and slower. So think about this whole tile set as like it's like Mars or Earth from very far away, and you're in a spaceship, right? And you're going towards it, but it's so massive that it doesn't look like it's moving at all. It doesn't look like it's growing at all, right? And then you get closer and closer, and it's just moving really slowly and slowly. And then you start to get into the atmosphere, and it starts to go really, really fast. And then you get down into, like, the trees and stuff, and now you're really going really fast, right? But that's only how it visually appears, right? The whole time, you're going the same speed, but visually, it doesn't look that way. So what we're trying to do is we're trying to adjust the zoom so that it's a little bit easier to work with, because this is kind of painstaking, right? So once we're in here, down to this level, when we're down at this level, the 1 pixel zoom is actually quite fast, right? Because this is 1 pixel, this is 1 pixel, this is 1 pixel, and this is 1 pixel. So when we're going by 1 pixel and zooming in and out by 1 pixel, it's actually nice and snappy, nice and fast. Like, this is nice here, but then as we go out, each little pixel is now displayed much smaller and smaller, so a 1 pixel adjustment of that camera becomes very painstakingly slow once we get all the way out here. So we want to fix that, right? We want to fix that kind of nonsense, so we're making a thing called NiceCam. And NiceCam is only going to be math that is used for polishing the camera code. So we're not trying to... It's not supposed to be camera code for the basic camera transformations. It's supposed to be a layer of abstraction on top of that, right? So, we can say, at vid, we can make a note of this, right? So let's go kind of like, before we, as we're adding things in here, why don't we make note of this, right? So, at vid IID 0158, and the time is 0003 0312 or 13. I like 13 better. And let's explain this after we get it kind of formatted nicely. So, NiceCam. Nice camera is what that means. And it is camera zoom/pan polishing code. 1 abstraction removed from the basic camera transformations. So it's 1 abstraction on top of. So we might want to say... So I'm just saying it in a different way, right? So 1 abstraction removed from basic camera transformations. That is true, but which way is it? And which way does that abstraction go? Well, it's a layering on top. This camera math goal here it to help with that's horrible grammar, even for my standards. So let's just say helps with helps polish, make nice the. So here's a little table of, you know, well, what does it help polish, right? And here's a little table of things down there for what it helps do, right? So we can decorate that a little bit. I know we're getting way too designy, but while we're here, we might as well, okay. Yeah. Okay, so it helps polish these behaviors. More user-friendly zoom by adjusting zoom speed as you zoom in and out to make zooming less painstakingly slow when zoomed all the way out. Camera drag/pan math functions to enable mouse to move camera rather than using keyboard shortcuts, right? Begin. Let's do 42. Okay, so we've just finished draft 1 of this summary. End summary. So we begin summary and then begin summary and then we ended summary, right? We began the summary here, we ended the summary here. Okay, so the camera zoom polish data is in this section. And this is table of zoom spans. So what we're doing here is we're saying that if the camera is I don't know why we... Oh, I see. So I don't think the camera can ever go... So I see one thing that's going to make this a little bit more regular. I don't think the camera can ever be 1 by 1. So this is saying 1 by 1 camera, right? There's no such thing as a 1 by 1 camera in the current setup here. It's all even numbers, right? So let's adjust this, and it's going to be a little bit more lopsided. But let's look at that zoom code for a second so we can understand this table and see how it needs to be edited. So if we go over here, go P for pattern, just throw something in here and try to zoom in here. If we keep on zooming in here, we're never going to get to 1 by 1 pixel. We're going to get to 1, 2, 3, 4. We're going to get a 2 by 2 pixel camera, right? And then over here, we want to go kind of fast. So this is, we never get down to here, right? So, okay, we start by, this is a 2 by 2 camera, 4 by 4 camera, 6 by 6 camera, 8 by 8 camera, 12 by 12, etc. This is the camera size. And we use different steps, right? At this camera size, we're stepping by 2, right? 2 plus 4. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. Once we get to 8, we're going to step by 4 to get these. Once we get to 32, we're going to step by 8. Once we get to 64, we're going to step by 16. Once we get to 128, we're going to step by 32. Once we get to 256, we step by 64 all the way up to 512. So you see how we're trying to move by powers of 2, larger and larger powers of 2, to cancel out the exponential effects of linearly approaching a large object from far away. If that makes any sense. I don't know if that does. So this is the basic math that we think that's going to work. So So let's make a note of what this is for, right? So this table might not be useful in the actual code for anything, but it is vital to me figuring out what tables up should look like. The lookup table here is just a listing of camera selection rectangle sizes. Example, 512 means 512 by 512 pixel camera rectangle size. Okay, yeah. So we don't actually know if this is going to be useful, but we're thinking, hey, it's going to help us solve stuff. It's going to help us. We don't know if we're actually going to use it for anything, but it's going to help us, right? So it's going to help us fill out the other tables. So 0, 1, 5, 8, and the time is 11. Let's just say 12 even, because it's about that. Date is 2021 02 26. Why not, right? So time. And this is the time stamp, right? So hopefully that's kind of obvious from the fact that, you know, there's 3 things there. Okay. So, yeah, when we're looking at this, this is just to help us with, oops. That's just to help us for down here, right? So, let's, camera exponent to pixel step, right? So we're in the camera exponent to pixel step section. We gave it a little bit bolder of a line. I don't know if I want to do that. I think that I want to stick with the other thickness. Okay. So, and also I need to do push-ups. Once we hit like 30 in time, I have so I'll have to take a break to do that eventually, which I will. Okay, so this is the pixel step for up, right? So we take the camera exponent, right? And then we get a pixel step when we're going upwards, right? So we want to say that for now, we really just always want the camera exponent to be like exactly one of these things. Otherwise, it might be kind of hard to know where to go. So we'll try to snap the camera to one of these exponential sizes, right? So 1, 2, 4, 8, 16, 32, 64, 128, 256. Or actually it is, Or actually, if we do find ourselves at 1, then the step would be... Yeah, we don't want that. One by one, camera should yield a 1 by 1, a pixel step. But problems. Okay. 1. Camera should never So the camera should never be an odd size, and it definitely should not be 1 by 1 in size. Okay. And 3, step of 1 implies edges are pushed or pulled by 0.5, which is not a discrete number of pixels. Right, it's not a discrete number of pixels, right? It's not a whole number. So, this is bad, right? So we're just going to say bad, and for now, we can just say we can just give it a 1, because that's the best possible behavior we can have. And so the next thing is until 8 by 8, right? So these sizes here if you're at 8 by 8, what are you doing? If you're at 8 by 8, you're stepping by 4. So let's go figure out what the math for that is, right? So, okay. Camera span to pixel step for push-pull. Right, that's what we're doing. Right, so we're going to take a camera span. We're going to figure out what camera exponent it falls under. So we're going to do something like, this is an array, and it got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 things in it. And we're just gonna say go to the bathroom. I'm gonna do my push-ups and stuff as well on my break. Try to make this quicker, but I'll give it give it 20 minutes just in case. And I want to have my push-ups done by the time I get back. So 20 minutes would put us at 44, which is still before midnight. So I'll be back. 150 per day. Yeah, so nice cam stuff. So we're going to take the camera span, and we're going to figure out what pixel step to use, right? So the first thing we're going to do, so I don't really think that I want to do this right away. I want to snap camera So in a section where I'm going to snap the camera to the nearest power of 2. And we're actually not going to do this. So first, snap the camera to an acceptable power of 2, and then figure out the pixel step needed for Alright, so basically I thought this is what I wanted to do, and I think that I don't want to do this. I want to do this kind of behavior, but this is not the correct interface. So we're going to take this, and we say up or down, but this is the down, and this is the up, right? So, we want to use these functions, right? And so we'll leave these in here to say, to let us know that we kind of decided that this function should not exist, and so we're going to code it explicitly so that we know not to do this, right? So we're going to define int32, and then we're going to define air as AAC 2020, nice cam halt, and then down here we're just going to undef int32, and then undef ERR. Can we do that? We're going to make a macro for that. So we can't define error because undef ERR, undef ERR, undef, or actually we could. So in our shortcuts, what we could do if we wanted to undef, if we wanted to, let me put this off screen. I have someone's address in a shortcut here. I had to keep that off screen. Okay. So if we want to undef this, right, we can just do like undef ERR, right? That's pretty easy, right? And then if we want to define error, we can go define, let's need extra space, and we can say ERR, and error will resolve to AAC 2020, system name, or subname, the subname space goes here, and then halt, right? So we could do that, or we could go 1, 2, 3, 4, 5, 6, 7, right? So it's more obvious kind of placeholder. We can also double click that and type what we need in there. So we can do define ERR, define ERR, and define ERR. And I don't know if this is actually going to help us, but why not, right? So we're going to add these shortcuts. So file new, define ERR as AAC 2020, 1, 2, 3, 4, 5, 6, 7, halt. And I'm just going to go through here and look for this. So in our shortcut files, in our CXX for C, it could be C99, it could be C11, right? So we don't really care because it's generic enough that it's going to work for anything. In our defines, we should make something called error._, right? And then we're going to make another one for the undef. So undef space ERR, which is pretty simple. And we're not going to put it in here, we're going to put it in the undef folder for the undef snippets. And call that err._. So now we have these different snippets. And for undef, right, we'll put sc files cxx undef, right? And then for here, we're going to do, instead of undef, we're going to go define, right? So define the error, undef the error. So undef the error, define the error, right? So paste file for both of these. Okay. So now let's, we're not going to be able to use those right away. So we actually just have to type it for now. But in the future, we won't have to worry about that. So let's go into the library. And this is nicecam.f, right? It's the functions file. And we need to say camera span to camera size exponent to pixel step for push-pull. That is kind of a large category. But let's not worry too much about that, right? So we have this section here. And within here, also this is not, 158 now is not mouse wheel, it's called Nicecam. So let's change that. Okay. Yeah, so in here, we're going to just directly use these lookup tables, right? So make it a little bit easier. Also, this needs to be a, if we were to make this function, it'd be int32 here. So just return, it's a problem. Right, so let's just make sure that it's kind of obvious. Okay, so over here, we're going to say int32 and AAC 2020 Nicecam, and we're going to do camera exponent, right? Camera exponent, right? The size in terms of an exponent. We're going to convert that to pick step, and we're going to go upwards, right? And then we're going to use the int32 camera exponent and get out what we need to get out. And the other function is going to be the same exact deal, except instead of going up, we go down, right? And for this, we need the same kind of stuff. So we need an int32 define as well as an air define. So we can kind of just steal this and we'll be fine. Okay. And when we are going upwards, we got to think about, well, how do we know... So we're saying that to make it easy, we just snap to a power of 2, and then we can just go through this whole array. So it looks like this is where I made a mistake, and this is where I stopped the previous video. So let's go 0158 for a second. Video 158, and the time is 0043. And let's just do 23, 4, 3, 2, 3. Okay. So camera exponent 9 is a 512 by 512, which would be a pixel step of 128. However, we're not actually going past 512 by 512. Okay. So if we were to zoom past this, we would use 128 probably. I'm pretty sure of that. But we have not filled out tables to support camera getting bigger than 512 by 512 pixels. So top equals 0 to prevent camera from growing more. Okay. So I like that. And, null terminated. We're going to make it a null terminated list so that I don't have to worry about how many things are in here, right? So we got 0, so right now, bad cannot be technically must not is the proper terminology here. It must not be 0. And, right, because that way if it's 0, we can't iterate through this. 11 entries, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We have 11 entries, but because we have a null terminated list, we don't have to worry about it, right? So what we're going to do here is we're just going to say while 1 equals 1. And we're going to take this lookup table. And... well, we don't even need that. We don't even need that because we're taking the we're no longer searching through this way, right? We're decided this is a stupid way to do it, and we're enforcing that the camera just has to be a power of 2. That's already in here, right? So the camera exponent size. So we start by 2 to the power of 0, right? Which is 1 by 1. 2 to the power of 2, 2 to the power of 1, sorry, 2 to the power of 1 is 2. 2 to the power of 2, 2 times 2, 4, right? Okay, yeah. So, we're not going to do a while loop. We don't even need that, right? Because now you can just directly use the lookup table, and we don't have to do that. But, you know what, we'll just keep it, null terminated anyways, just because that could be helpful in the future. And we're going to, we're just going to say, and assert camera exponent the last valid one we're using is 8, right? So if this assert current lookup table supports this, right? So before we use this, we want to use a value that we know that is going to work for it, right? And then this is called pick step. So in32, pick step equals this, right? So the idea is that we can directly use this lookup table to get what we're looking for, and then we can just return it, right? Now, we don't have to think about interpolations between these different values, because we're just going to snap to certain values anyways, and we're just going to keep it like that for now, right? So I was just thinking about it's more like an editor camera, right? If we think about NiceCam is kind of like vague, it's more like editor camera math, right? Because I'm thinking that there could be other. This isn't a nice camera movement in terms of what would be nice for in-game play, right? Like, there's other interpolations that would be better for that. So I'm gonna change this to EDITCAM. Yeah. Anything wherever I see NiceCam, I'm changing my mind here. So if we see NiceCam, we're gonna change it to EDITCAM. We're gonna match case. Okay. And then over here, we're gonna do the same thing. So we're gonna look for NiceCam, and we're gonna change that to EDITCAM. Match the case. So this now is going to be So we'll keep NiceCam here. So we have a reference to this original thing that we called NiceCam, and then conceptually we're going to think of this as NiceCam.EditorCamera, right? But this is editor camera, and it's supposed to helps polish make nice these behaviors, right? And so these behaviors are for the editor. So we can make an update to this. Right, so update, date 2021-02-26, at vid IID 0158, and the time is 0051 and 32, because I like powers of 2. Okay, so what constitutes a nice camera behavior differs depending on if we are editing a level or if we are playing a game. So instead of nice cam, we need EDITCAM, camera editor math polish to camera in-game both libraries build upon the tau type rectangle relations directly edit the camera the camera data rectangles. That didn't work. VP is 0 means like that, maybe. Destination / screen viewport. Wrong. So I want VP1 means. That is off screen, yeah. Okay. So yeah, this is a big kind of like update. Of what we are talking about here. So let's also make a note of, let's change this around. So let's make a note, this is started writing. Time, I don't know yet. 00, say 5600. Explaining. Done writing, now explaining. Okay. Okay. So, not 32, let's say, how about 42, right? Because I like to be cool. Okay, so let's explain what we just wrote here. Okay, so what constitutes a nice camera behavior differs depending on if we're editing a level or if we are playing a game. So instead of nice cam, we need EDITCAM, which is camera editor math polish, and then we need GAMECAM. And GameCam is going to be camera in-game math polish. So it's not object-oriented in the sense that we have like a editor camera class and we have like a game camera class, right? These are functions for an editor camera, and these are functions for a game camera, right? So there may be multiple editors that use the editor camera, and there'll be multiple game states or game modes that are going to use the in-game camera math, right? So it's not OOP. Make a note of this. That this is not okay. So we might make a note of this, right? To say not OOP. There is no EDITCAM object there is no GameCam object. There may be multiple editors that need to behave using EDITCAM functions. There may be multiple game mode editors that may need GameCam functions. Right? So I want to make a note of that it's not object-oriented programming, and so we've screwed something up with this. Oh, this is wrong thing. So let's make a note of this, right? So say we kind of ranted here. And 5.8, how about 23 to keep up with the conspiracies? Okay. So anyways, both libraries are going to build upon the tau-type rectangle manipulations that directly edit the camera data rectangles, also known as viewport 1, and viewport 1 is the off-screen /source /tile map bitmap data viewport. So it's a selection rectangle that goes over the data. Or in other words, when I say data, I mean like a tile map itself is data, right? So if you take a selection rectangle over a tile map and you shrink that selection rectangle, you zoom in. And when you make that selection rectangle over the tile map bigger, you zoom out, right? So, so the way I'm writing this code, right, is I'm writing it in a data-oriented way where there's a lot of abstractions that might be missing, where instead of, right, it's just called VP1, and VP1 goes over the data, rather than saying that it is, rather than saying it's the world camera, or something like that, or the world camera, or the tile map camera, or something like that. It's strictly a data camera, right? It goes over the data. And then the VP0 is what maps to on-screen, right? VP0 is not then here so yeah, in here, VP0 is no concern here, right? So let's make a note of this, right? So at and let's just call this 50, right? So yeah, VP0 is not relevant here. VP0 is the destination /on-screen /client /canvas rectangle that we map VP1 data to, right? It's the destination rectangle, okay? So that is a lot of information, right? That's a lot of explanation-y kind of stuff here, right? Before we even get to the data, right? Well, that's fine. We want to know what the heck we're doing, right? So yeah, we're going to call it NiceCam. Actually, we're not calling it NiceCam anymore, right? So let's rename this. So we're going to rename this to EDITCAM.data. EDITCAM.data, right? And over here, we're going to rename this to NiceCam.function. So, or sorry, EDITCAM.f. Okay. Now the next thing is, we know in the far future we're going to need something called GameCam, and it's going to need to edit. It's going to need to do some transformations that are friendly to when we're in game, right? So the question is, do we stub in GameCam and EDITCAM like right next to each other, because we know they're going to be needed. But what if in the future, once we get to the GameCam, we realize that there's more data than we anticipated that we need for this, and they shouldn't actually be next to each other. I'm going to say that they can be next to each other. I'm going to say that they should be next to each other for now. And there are abstractions that build on top of tau type, right? So we should put it like right after tau type. So this pixel step thing, right? So we just look in here, and then this one is just going to be lookup table for the other thing, right? So this is the down. So we're going to say dow, and we still need the same kind of thing here, right? So just two lookup tables. Let's do dash line I1x64. Let's separate this a bit so that we know kind of what we're looking at. When I look in this section, I want to immediately know that there's more than one function in this category. And so one way I'm going to do that is by having these dashed lines. So if I see this header section, and I see this dash line, without even seeing this down here, you know, if I'm zoomed in like this, I'll never be zoomed in like this, but I can know from seeing this and seeing this that there's more than one function in this section just by the way I'm writing the code. And we should also, even though this is a section of code that we're not meant to invoke, we should probably still keep with the same kind of formatting. Okay. So now the next thing is, if we look at the tables here, we have this table kind of built out, but we need something that goes in the other direction, right? So this is the up table, right? And so we want to know, okay, yeah, so we stop by this until we go that way, right? So we want to know, well, what happens in the other direction, right? So, so the first thing is, let's just take this, right? And we're going to think that we need 11 entries as well, but I don't know. And we're just going to nuke this for now, right? We're going to nuke this for now. And if we're at so it's the same thing with this first one, right? Where this first one is bad, right? So if we... That is kind of weird formatting. Hold on. Not indented far enough. And this is wonky. Well, I don't know why we have that kind of indentation, because nothing else has it. I would like the indentation to be a little bit less wonky here. Oops. Okay, so over here, the first value is bad, right? We don't want this first value. Now, if we get to, we're not going up anymore. We're going down, right? And we're thinking that, you know, we need to reverse their steps, right? So we're going, so all this stuff, this is an 8, and we add 4, right? But if we're at 8 and we're going down, we're minusing 2, right? So we can know that So we have 2, 2, 2, and camera. So camera exponent 1. And let's keep the same exact thing, right? So camera exponent 1, 0, 0, 2 by 0, 0, 2. And if we're at 2 by 2, if we're at 2 by 2 over here, this is a 2 by 2. Well, we really don't want to go down any further than that, do we? Because if we go down any further than that, what do we end up at? We end up at 0, right? So, so this here is the, we've bottomed out, right? So this is, we've bottomed out, and at the bottom, bottom also gets 0, right? So define bottom, right, so if we bottomed out, we can't move further. Now, if we do that, though, we're kind of... We're going to change what we wrote there just so that we can get this in here, right? But we've bottomed out, we can't move, right? And then, so for this thing here, top, bottom, and bad. So top, bottom, and bad. Okay. So yeah, if the camera exponent is 1 that's a 2 by 2, and we can't go down any further, right? Now, if the camera exponent, so 0, 1, and 2, right? So we're making this a lookup table. So this is 0, this is 1, this is 2, right? And over here, right, 0, 1, 2, right? Because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It's based on the index that's getting inputted into the lookup table. Well, 2 is the next... also, camera exponent 1, is that 2 by 2, or is that... yeah, because 2 to the power of 0 is 1, and then 2 to the power of 1 is 2. So, yeah, okay, so this is 4 by 4. And that should equal 2, right? So if we're in this 4 by 4 section, right? If we're 4 by 4, we're over here, and we're in the 2 incrementing section. So going backwards from a 4 by 4, we minus 2 to get to here, right? So we're good there, right? So, and we don't want to, this is wrong. Wrong. Snap to nearest value in... Yeah, this is wrong. What we actually want to do is we want to snap to the nearest value in this kind of lookup table here. So we don't actually want to snap to the power of 2 to make this make sense. We want to snap to... yeah, that's wrong. So we're going to make a note of that. This is wrong. We don't want to do this. Okay. Because I thought about it, and yeah, that's not what we want to do here. So, snap camera to we want to snap the camera to editor friendly values. Let's not call it editor friendly values. I mean, that's kind of what it is. Let's say to preset values, right? And right, so before we oh, I see why we want that. Okay, I see kind of why we might wanted this nearest power 2 thing. We'll figure that out. So if we do need the nearest power 2 thing, it's going to be up here, and this thing will utilize that somehow. But yeah, so we're saying that the camera should be kind of snapped to these preset values. So, so we're gonna take the camera span, right? That's the M32, and we're gonna snap it to something, right? So we're gonna use this table, right? And we're gonna, I don't know what goes in here, some number. I might finish a lot of this code at the shop, since a lot of this code is kind of redundant. Or not redundant, but it's kind of, there's nothing really weird. So what we're going to do is we're going to go through this whole list here. And 0 is an invalid value, so we're going to try to just null terminate this list. We're just going to keep it a null terminated list, so that way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we think there's 27 things in here. I could be wrong with that count, but we'll assume that's 27. And this is table of zoom span, right? Okay, so while 1 equals 1, we want to figure out what we're between, right? So we want to figure out the value that we are so if cam san is greater than or equal to lookup table. We'll just call it lookup table. We could just call it tab for table. And then we can go over here and can say, you know, define table, right? And then on here we can go undef table. And the other thing is, some of these things where we made it all capital, I don't think that's right. I think that I get why we want to do that, but camera exponent to pixel, this is more like a private function. This is more of a private function. This is more of a private function, right? So let's change some of that, right? Private function, EDITCAM, camera exponent to pixel step. It does make it a little bit harder to read because now to visually parse this, but it really is more of a private function, so let's kind of conform to that. Okay. And these tables of data, I mean, we'll keep the data public, right? We're not trying to encapsulate anything, right? So if we're not trying to encapsulate things, then maybe we should err on the side of just making the data public. I don't know. But okay, so right over here, we have this table, and we have this dex, right? It has some type of index. And then, okay, here's something. So if it's greater than if we're greater than the, actually no. If we're greater than or equal to the last index, oops, right, so if we're greater than or equal to 512, and then the next thing here, right, uh, 448. So the current example right here is 512 and 448. If we are greater than this, and we're greater than or equal to this, then we need to snap to the last thing, right? So outsan equals camsan equals the table 0, right? Okay. The last thing we want to know is else. We'll look through here, right? We'll go loop in through here. And if not found, then we want the last index, right? We want So dex, there's some type of index that we're incrementing, and we stop when we get to this null terminator, right? So we're gonna back up dex -1. Take last entry before the null. Alright, so we're going to take the last entry before the null terminator in the list, is what we're going to do here. So we have an int32, which is our output span, so out span, output span, and that is going to equal 0 minus 666, which is a trap value, right? So a trap value, in case we don't get this correct for some reason, right? So the first thing, you know, if we're just way out of bounds, upper bounds, right? Like, we're just gonna way too high, take largest value we allow for the camera span. Okay. And if this does not happen, then, well, 1 equals 1. And if the camera span dex plus 0, right, if we are less than this, right, we're less than or equal to this, but we're greater than or equal to this, right, we're between that range, then, so less than or equal to, and cam, not CanSan, CamSan. If it's greater than or equal to TADE, dex plus 1. And we can get away with this because so if we hit this, we hit the null terminator in the list, and we can't do this, right? Now, if we hit this, then found equals 1, right? We found it, and if that's true, then we want to figure out what we're closest to, right? So int32 cam minsan equals table or maxsan, right? Maxsan equals the table dex plus 0. And then int32 minsan equals the table dex plus 1. And AAC 2020 EDITCAM closest. So, san, we're going to take the camera span and we're going to snap to the min or max, right? So this is snap to snap the camera span, right? And this is going to snap to min and max, right? So we're going to take the cam san, right? Cam san, which is the input, right? The input right here. And we're going to snap it to the min and the max. So, min and max might be kind of like GLSL, not GLSL, but C99 functions, so I am worried about that. So, min C99. Let's make sure that we're not interfering with some type of standard library, right? Min and max. Min standard library C99. Let's say C99 just so that we don't. std min. Yeah, so I am worried that min is something that is in the standard library, so we don't want to make a variable called min because it could interfere with a function name, so we don't want to do that. Also, let me check something. Here's my thing. Let me go title screen. NiceCam is not what it is. We are actually calling it, we decided it's not NiceCam, we've decided it is EDITCAM, right? And let me check some other things here that I was doing. 44%. Okay, let me go back here. Okay, so that's fine. So to min-max, so I don't really want to call it min-san, max-san because it's long. Min-san, max-san. But that makes it easier, right? Because we know exactly what's going into this function, right? We're taking the camera span and we're snapping it to min-san and max-san. So whatever is closest, right? We're going to snap it, right? So let's just take this. And that is kind of ugly, but let's just go with that. So cam-san equals, or actually out-san, right? So out-san equals this. Right, so the output span equals this, and we found it, right? And this is if we're in here, right? Out-san we already collected here if we're all the way up at the top, very top, right? And if we go through this while loop and we don't find something, right? Found is less than or equal to 0, right? Found is not found. Then the output span is whatever was before the null terminator. And then down here, we can assert out-san less than or equal to 512, and out-san greater than or equal to 2, right? And then we can return out-san here. Return out-san. Okay. And then we need a found variable, so UO8 or IO8, because we only might as well make it signed because we're only going to use the value 0 or 1, so might as well make it signed so that we can found equals 0, right? So it's set to 0 to begin with. Value found. Okay, and then in here, we have found right here. Now, we don't really need it outside of this scope, do we? So, why declare it in this scope if this is where we need it? This isn't C9. This isn't C89, so we can write it like this, and that's fine. So else found equals 0, found equals 1 here. If found is less than or equal to 0, then the output span is that, right? And output span is right here. Okay, yeah, so that's good to me. Good for me. Now, before we kind of go any further, we really need to, first of all, 158. We're on video 158, right? Yeah, 158. We decided it's not called MiceCam, it's called EDITCAM, right? So, let's change the title there. What now? I mean, there's a lot of other stuff we could do, but I'd rather just be done for now. But before we are done, well, first of all, can we still compile? We should still be able to compile because we haven't actually, we haven't included any of this code we've been writing into our project. So it may or may not be broken, but we're not going to find that out because it's not included in the project yet. So before we kind of go here, right, before we kind of like give up for the day, I want to include it into the project, and we're not going to, I don't think I'm going to fix this zoom issue today, but I'm going to have everything kind of stubbed into where it needs to be, and then maybe write some more code at the shop to help fix this. Also, I might want to take a GIF recorder of what I got here. GIF recorder. Let me just get a GIF recording of this. Because I do want to show... I want to show my artist what I have so far. Because I know they've been waiting... They have been waiting for maybe almost a year now. I don't even want to think about it. We started this in 2020. It's now 2021. I made like a prototype in JavaScript. Then I ditched JavaScript and started rewriting it in a different language. And so there's been a lot of stuff going on here. They have been waiting patiently. So let's kind of screenshot this to kind of like so let's go record, boom, 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 P for pattern, right? And then zoom, 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 zoom. And then I think it's like, I don't remember what the arrow keys are. You know, I thought I did. I think it might be like I. Yeah, that's what it is. Okay, so it's like I, JK. I'm going to try that again. Stop. New. And let's just do 0, 1. If I go back here, everything kind of resets. We'll have to fix that, right? Because we don't want to nuke people's stuff when they go between editors, right? So let's also kind of center this a bit, right? Let's try to get a better idea of what's going on here. I want to get something to where I can kind of show it off a bit, right? So, so we're over here. Let's record. Okay, so over here, we press this button. We can go boom, boom, boom. And then I think we can go D to go down a size. No, it's W. And then we exploded, huh? Okay, well, let's not try to explode. Let's just show off what we have, because there's still more to polish, obviously. And we are breaking things. So, new. But yeah, let's just kind of show what we have. So I, J, K, and L seem to be like our zoom, our panning keys. So let's just show off what we have. So we're going to record. So this. Okay, and then we go P, we go over here, we go bam, bam, bam. And then, I don't know what the tile size was. It was like down. I know we had a thing to change the tile size. Yeah, it was like X's. Yeah, like this. Right, so this. right? And then we can kind of zoom in. And then we can kind of go P for pattern. And then we have the zoom. And then we also have the I, J, K, and L. And then we also have... Okay, and then we're going to stop there. Okay, so not the... It still needs a lot of work. But I want to show my artist that I actually have something. So save, and I'm going to just say it's in delete me for Josh 2021 0227.gif. And it needs more work. It definitely needs more work, but it's at a point where I can say, hey, check this out. I have some stuff, right? I have some stuff. It's doing some cool things. Let's show our artist what we have, right? So I'm going to go into Discord really quick. And I'm going to send that to him. So it's named for Josh something something dot gif. Also, I know my GIF recorder software is probably stupid, so let's go into, I'm going to go into my desktop, go into the delete me folder, go find that for Josh file, because I bet it's named like .gif. Yes, it is. So, right, because I like the capital extension, and it doesn't know what the heck I'm talking about when I do that, so I got to change that. Okay, so now that that's changed, I can't really show you what I'm working on here. I'm just gonna go back to the title screen image for this, because I can black out my screen here. And I'm gonna go find Josh on Discord, and I am going to send them this. So for Josh 2020 something or other. Okay. Upload. Okay. Working on editor controls, and then fine-tuning rendering colors to be artist friendly to your working style. Right now, editor uses debug colors that I can use to verify the integrity of my rendering logic visually. Okay, so I just want to make sure that what I'm saying here is okay. It doesn't look like doesn't look like there's anything. Doesn't look like there's anything confidential here on my Discord in terms of what we're chatting about on screen right now. So, all right. So I just sent this to them, and right. So working on editor controls and then fine-tuning rendering colors to be friendly to your working style. Now, why the heck can't I play this? Do I have to click it? I don't know if that's going to open anything, so I want to put it up on the other screen really quick. And if I click it, if I click Open Original, okay, so if I open Original, I need to be a little bit faster about that. So I'm going to try to do another take of that. Because I did not like that. That was, like, it was close to what I wanted, but not exactly. So we're going to do another, so we know I, J, K, and L, is what we need to kind of go pan, and then I, J, K, and L is what we need to pan, and then X to make the brush smaller, right? So let's just kind of go up here. Let's try to record something, because I noticed that I was slow on the punch up to doing stuff, and as I was looking at the GIF recording, I'm like, somebody's gonna stop watching this halfway through before they get to the good stuff, because it's just not it's just taking too long. So we're gonna try to fit this, try to make this. We don't need to make it too big, right? It just needs to be, just needs to fit. Okay, so we got this. So are we ready? So we're gonna go 0, 1, clickety click, XX. So okay, record. So here 0, okay, and then 1, and then we're gonna click, and then we're gonna go X to go smaller. Then we're gonna go X to go smaller. We're gonna go X to go smaller. We're gonna go smaller, and then after we've gone small enough, we're gonna try to zoom in a bit. Right, so we're gonna zoom, 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 and then we're gonna do like, right, we can zoom like this, and then also we can do P for pattern, and then we can go like this, and then we can also zoom out like this, right, and then we can also zoom back in, and then also we wanted to just demonstrate that we can kind of like do this, right, we can kind of move. And then we can also, if we go down and we set tile values, we can go down, and we can set tile values, but I'm not actually seeing anything, so we're gonna stop. Okay, so I'm gonna save that. So save, and I'm gonna save it as. Well, actually, it's already in the delete me. So I'm going to save this again as for Josh, whatever the heck. So in desktop, in the delete me folder, for Josh 2021 0227 number 2 .gif. Okay, we're gonna close this now. So Control C over here. And I think that's a little bit better. I think that's a bit better. And then we'll stub in this system, as well as we'll stub in GameCam and EDITCAM into the system in the proper kind of place where we think it belongs. But also I'm going to put this on Imgur. So I'm going to go to Imgur and put it on Imgur for a second. And I have some stuff on Imgur I probably shouldn't be showing publicly, so we're gonna keep my Imgur off screen for now. Not technically, it depends. There's some edgy stuff on my Imgur, and then some slightly not safe for work stuff. It really depends on your company culture, depending on if you think what I have is not safe for work. Like, there's no nudity, but there's some suggestive stuff. So for Josh, number 2, open that up, and okay, so let's just, we can take a look at this now. We can actually drag this down here. We just want to see what this GIF looks like, right? So, we got the little clickety clicks, and then we kind of zooming in, right? Okay. Okay, I did this, and then I can kind of like pan. Okay, yeah. So we're getting better. We're getting better. So that's a good little preview of what's going on here. So I like that. Let's just take this, copy that, and let's go show that to Josh, right? So that's pretty good. Oh, well, I said I wasn't going to show anything, and then I'm going to get myself canceled here. So unfortunately, no one's ever going to see this, right? I only have, like, what, 62 followers and not that many viewers on what do you call it? Not that many viewers on YouTube where I archive things, so it's going to be one of those things that it's like somebody would really want to have to come after me to, like, look through all my videos and find me. No one is going to work that hard to cancel me, I don't think. Yeah, that would be weight. Anyways, let's not worry about it. Anyways, this video better demonstrates what is going on. First of weird blue and black pixels on white is a memory viewer for me to debug stuff. The light blue squares showing up on white canvas is the editor is painting in a blank tile set. And am I actually showing you what I'm typing right now? Yeah. And then the strobing to other strobing red and blue stuff you see next is a preset loaded pattern stored in engine code. Loaded tile set design stored in engine code. Lastly, demonstrating zoom in, zoom out, and panning. Not ready for you yet. 1, colors are shit. They are just programmer art debug colors to verify integrity of rendering code. 2, zoom is painfully slow because zoom is linear and linear speed thus appears to move very slowly when far away from everything and appears to speed up when closer, as is the nature of a real-world perspective, but not friendly for an editor. What's the other thing? Pan really needs to be done with mouse rather than keyboard. I want basic controls. 1, click to set, unset tile. Mouse wheel to zoom in and out. And this is left click. 3, right mouse to pan the canvas. 4, other keyboard controls for brush color and brush size. Also, 62 followers on Twitch. I do see that some Twitch game dev streamers mention that doing their dev work on Twitch has made it so they don't need to seek advertising or publishers. So crossing fingers that as technology gets more badass for this renderer, that I will get more and more viewers quicker and quicker. I think that's it for now. Sorry this is taking forever, but not stuck. Still have a very clear vision of what everything must do. Also, if you want the whole elevator pitch tech demos speech sometime, get on Twitch and ask. And I'll go through some of my thought process in a way that hopefully makes things clearer. But yeah, everything is kind of abstract at the moment, and so it kind of just have to trust that I... What up? Okay, yeah, so anyways, I'm just gonna keep keeping them up to date on this, and yeah. Anyone messaged me? Oh, I might want to see who is that messaging me there. I don't know, it's personal, so I'm gonna keep it on a different screen here. But the couple of times I've tried, I've noticed that it's much more other effects. Oh yeah. I just... Okay, so anyways, I'm done there. Let's start stubbing this in, right? So we took some screenshots, and now we just wanna get this system stubbed into a place where we think it belongs. So if we're looking at this and we're trying to figure out where it goes, well, the first thing is we want to click this, right? We want to click this so we can see these systems. And are my editors shuffled out of order again? Yes, they are. Let's put this over here. Okay. Come on. Okay, so this goes over here, and... God, we still have way too many things open. Okay, so we got all these systems, right? And we want to know where this goes. Well, we have tau type right here in tau sync. Now, if our functions are going to edit tau types, right? Like it's an abstraction on top of that. I do like the tau things being grouped together, so I don't really want to insert things in between tau type and tau sync. Even though we're going to build on top of tau type, right? So since this camera logic does build upon tau type, I'm going to put it over here, right? So we're going to take these functions here, and we're going to go bam, bam, or not functions, but macros. So 41, 42, 43, 44, and 45. So 43 plus 2 is 45, right? We're going to compile up to 45 now, right? And This is going to be called EDITCAM, and this is going to be called GAMECAM, right? Because I know I'm going to need something called GAMECAM in the future, and I don't want to keep both camera logics in the same file, because it's going to be a totally different domain. The way the edit camera needs to behave and the way the game camera needs to behave are different. Now, the game mode is actually going to be an editor itself, but when I mean edit cam, I mean an editor that behaves like a normal editor, and when I mean game cam, I mean an editor that behaves like a game, which is kind of weird to say, but the idea is that the project is very editor-centric, so everything is an editor, right? Or, well, not all of these systems are an editor, but all of these systems that are that get a number key, right? So all of these systems that you can, the number keys 0 through 9 to get to a different important, like, top-level subsystem kind of thing. Those are all editors, right? So this is like all of the sub-libraries that make up everything. And then Paint 5D is like a top-level editor, and then GPU View is a top-level editor. That is kind of weird. It's a little bit kind of interlacy, kind of meh. But that's the way we're going to do it. So we're going to say nicecam dot editors nicecam dot game control, right? So we got editor control, we got game control, and they're both nicecam things, right? So originally we were going to call the thing we were working on nicecam. So we're going to keep this nicecam thing here for us to just remember the origins of where this came from, right? And we also want to stub in this, right? So we want to stub in the edit cam, right? So or game cam dot abstractions built on top of basic camera transforms in tau type to make camera more user-friendly in the context of gameplay. Okay. For camera abstractions, related, see edit cam, right? So here, let's just say gamecam.d. And if we're going to stub this in, we might as well so you can just say nothing here yet. Stubbed in into its most logical position within libchan. Libchan, because I know I will need this code in the future, but not at the moment. So you could say that we're like violating Gagny, right? The idea of you aren't going to need it, but it's not a... I've done enough of this stuff before that I do know I'm going to need it, right? I'm not making this up. I mean, that's a pretty bold decision to say, you know, you can see that far in the future. But in any game, you need camera controls that are gonna, like, you know, you have like smooth camera transitions and follow the player and all that kind of stuff. So we know that something in here needs to be for that kind of stuff. Now we could be putting this in the we could be putting all this stuff in the wrong place, right? There's the potential that we are kind of putting it in the wrong place, but it's better to stub it in now, I think, so that we don't forget about it. And also, right now, if we can get away with it and keep it this way, it would be nice to keep both these camera things right next to each other in the dependency hierarchy, right? So, yeah, that's how we're going to do it. And they don't depend on each other, right? So, this could be in any order. These two could be in any order, because GameCam and EDITCAM both build upon the tau type. So this list you're seeing is not a... there's many ways we could have made this list. This is just one possible solution for a tree of dependencies, right? So we're basically this is one solution for a solved dependency graph, right? That is what you're seeing here. Okay, so anyways, I like that. Let's call it GameCam, GameCam.d for data. And then, for this, for the function file, we are actually going to stub some stuff in. So, halt is, that's 489 paste. Even though I don't even use that, but I remember what it is. So, GameCam halt, right? And then we're going to say GameCam over here. And then over here, we're not going to use that. We're going to use the number that it currently is. So right now, GameCam is system number 43. This isn't a very important thing here, but I'm just trying to give it something that's not completely arbitrary. Okay. And then we might as well make the other boilerplate. Why not just paste AAC 2020 boilerplate? So that's wrong. So you mean paste AAC 2020 boilerplate. Paste AAC 2020. I don't think that I have an underscore version of this, though. Paste AAC 2020 boilerplate. No, I don't. I have something very close. Use... So the date is 2021-02-27, right? And what about AAC 2020 boilerplate paste? I mean, while I'm here, might as well. AAC 2020 boilerplate paste. Nope. Not that either, so we're just gonna say let's call that A, call that B, and right, so I know what we mean, like use this, right? Yeah, sure. Boiler paste. I say boiler paste. Boiler. Try NSSBP paste if AAC 2020. Okay, yeah. So yeah, we're just gonna take these shortcuts, and we're gonna put them in our shortcuts, right? We're gonna put it in our master shortcuts file, so that we have access to it later. Okay. And now we're gonna say right, NSSBP paste, right? We're going to look at what that is. So we have the halt, we have the log after halt, we have the init none function, and that's exactly what I want, right? So we can take this, typically the first function thing, we already kind of did the refactoring for that, so let's not waste that effort that we already did, paste that there. And then over here, we just want to look for all these, and we just want to replace them with the correct thing, right? So this is, we're in EDITCAM, right? Or we're in GAMECAM. GAMECAM, info any. This one's we're going to call GameCam. And then this is going to be GameCam. And this over here is going to be called GameCam. And nothing's going to go on in here yet. It's just going to init none. It's not actually going to do anything. And this is gamecam.f._, right? So it's my functions file. With that, we need to, what do we need to do here? So in silence, we actually have to go into silence and add these as well. So lib and go into silence dot data, right? And if we look at this, our boilerplate for this actually needs to be changed. So this needs attention, right? So the boilerplate isn't quite the same anymore. Because of the overriding behaviors that we have. So let's go take, so we're saying that after tau type and tau sync is where we want to make these entries, right? So right here, we're saying that we want to do, it doesn't really matter the order, but we want to keep the exact same order that we did in here, right? So EDITCAM and GameCam, right? So EDITCAM, right? Because we need an editor camera before we need a game camera. Because if we don't have the pipeline for editing and creating levels, then we can't actually have a game cam because we have no valid data, right? So it makes sense that logically the editor camera would come before the game camera. And then down here, right here, right, we're gonna go boom boom, and these new things need to be on by default. And we're gonna call this EDITCAM. And we're going to call this one GameCam. Okay. And now that we have those kind of put in there, we got to look at something kind of newer that has the correct kind of like format. And format for the, I don't even know what has the correct format for this kind of stuff. Tau type, do we really need this open? We were looking at this, and our unit test passed for this stuff, so I don't think we need to look at this anymore. But yeah, this kind of boilerplate is actually what we need. This looks exemplary for what we need. So I'm going to copy that, and I'm going to close this. And we're going to go File, New, and edit AAC 2020 boilerplate. Okay, AAC 2020 boilerplate edit. Let's make sure that this doesn't already exist, and maybe we tried this and then we didn't reload our shortcuts and it actually is in here, right? Okay, it's not. So, well, we know that we have NSSBP and then maybe we have an edit for that, maybe? Nope. Edit NSSBP. NSSBP edit NSSBP, right? Because we had the paste, right? So we're just going to say use NSSBP edit if AAC 2020. Right. And if we have this, we just want to figure out, well, what is that? So NSSBP paste. So let's go find, I'm going to go find that shortcut, and I can find the file, and now we have an edit command for that. And it may seem kind of tedious that we do all this. It's like, just go find the file and open it. Like, what the hell is your problem, right? Like, just go find the file, open it, and you're done, right? I'm sure one of my bosses would kind of give me that attitude. But the thing is that I want to be able to find this stuff, like, 5 years from now, I want to be able to find this stuff. right? So we want to make copious amounts of shortcuts so that we don't lose work to time, right? Like, if there's something meaningful that we coded 5 years ago, I want to be able to find that relatively quickly, right? Like, if I did it 5 years ago, I would like to be able to find it in under 5 minutes, right? So let's say, you know, that could be a good rule, right? For every year that I made it, 1 minute to find it. So one year ago, 1 minute. 2 years ago, 2 minutes. 3 years ago, etc. I don't know, 50 years ago, 50 minutes. I'd rather find it faster than that. If I know about it, I should be able to find it relatively quickly, right? So if I know about it, even vaguely, I would like to find it in, like, you know, under 2 minutes. And so we're going to need a lot of shortcuts to make that happen. So we have this, and this is a pretty good snippet. And we just want to, anywhere we see tau type, we're just going to say, change this with, so tau type is, so one kanji, another kanji, and then up, right? UPP. So I'm thinking, namespace K, namespace kanji, lower. So this is the lowercase thing here. And then this thing right here is uppercase. Right? It's not completely aligned because of the font I'm using. But the idea is that it's not gonna compile if it sees this Japanese in there. And then I can just be able to easily find this, right? Where, first of all, I can just color these things and find what I'm looking for. But also I could just highlight upper and lower and find it, right? So it's a nicer snippet in that aspect. So we're going to go here, and actually, no, we're going to go open up the original snippet, right? So we're going to go File, Open, and we're going to look for AutoHotkey CXX folder, or AutoHotkey AAC 2020 Snips folder, right? I don't think, whoa, did that work? No, that didn't work. So we want something like, you know, AutoHotkey 2020 AAC Snips folder, AutoHotkey AAC 2020 Snips folder. AutoHotkey AAC 2020 Snips folder. So that was actually quite close, right? So AAC 2020 Snips folder, right? So it was just the AutoHotkey that we're missing from here, right? So we can do this. We can take this, and so next time we paste, next time we prefix it with AutoHotkey because we're crazy, right? We can find this as well. Okay, so we'll paste that in there, and okay. So let's go File, Open, and we know that it's, you know, called AAC 2020 Snips folder. And we're hoping that's actually where we want it to be, right? So that does look like where I want to be, right? It's in AA2, AAC 2020 Snips, and we have log after halt, and then we have new subsystem boilerplate. We want to open both of those because we want to take this boilerplate we've been writing, and we want to put it in both places. So that's kind of ugly, but that's the way we're doing it. So this log after halt, right? This thing here. Now log after halt looks like this, right? Because we want to accommodate both of these overrides, right? So if silence is super off, then no one is silenced and everyone gets a say, right? If silence is super on, then everybody gets to shut up, right? And if silence is just 0, then there's no override, and we use the default behavior of whatever is configured for this system, right? So wherever this system is, wherever its flag is set for, will determine whether or not it's going to blab or not, right? So the default, we're going to turn it off, but if this is flagged to say, oh, you have not been silenced, so you've not been silenced, if this system has not been silenced, then it will talk. And I know I'm kind of describing this over again, but the thing is, I want to make absolutely sure my snippets are correct. So, like, I'll keep on using the same snippets, which helps me not make mistakes in my code. And then every time I use a snippet, sometimes I'll kind of re-explain it, and that gives me a little bit more double checking to make sure that that's correct. So log after halt actually looks like it has already been updated correctly, right? So it has the lower and upper, right? So slightly different, right? Because instead of saying lower, is this 1, 2, 3, 4, 5, 6, 7? So that's not actually 7 letters. So actually, I like this a little bit better because it's closer to lined up, right? If we do up and low, right? So let's save it like that, and then we can still highlight upper, we can highlight lower, and if we highlight any other kanji, it's still in all those places. That looks good. Okay, cool. So we're done with that. We can close that, and we can paste log after halt. I don't know if that's going to work. Log after halt paste. Okay. So I believe it's 489 paste that we're going to use for that. Use 489... Oh, actually, no. That's not correct. Log after halt func. Paste log after halt function. Paste log after halt func. Okay, let's kind of put that in there. Put that in our shortcuts so next time. So I don't know what this snippet is actually called, right? So I know one's called 489 paste, but I don't know what this one's called. So we're gonna think about that. We're gonna figure that shit out. But and then we're gonna paste a file. So we can actually just open it up, right? Rather than worry about it, we can just go. We already had it open, right? So log after halt, it's this thing right here, right? So full file path to clipboard, close it. I don't know what that snippet was supposed to be. I'm not going to worry about it. I'm just going to say paste file and say we're done, right? Or we could say, oh, you know what? It's info any paste. Okay, so I do want to kind of like make my mind reinforce certain pathways. So instead of just making all those phrases I typed paste what I'm looking for, I want those phrases to have one level of indirection that will reinforce one master shortcut that I want to absolutely make sure I remember. So info any paste, if we do this, right? Log after halt, and here's all this stuff, right? So now that we have this in here, right, we can say, okay, well, this needs to be GameCam, right? So take this and take this, right? And this is going to be GameCam, and then over here, this is GameCam, but all uppercase, so GameCam. And then this is GameCam lowercase, so GameCam. That looks good to me. And then GameCam and it none. That looks great. It all looks good there. GameCam.f. And this is not anything that is going to be... we're not actually going to put any stuff in here, right? It's just enough stuff to get the system stubbed into place, but we're not actually going to use it for the time being. GameCam data, right? Nothing here yet. If we want to, maybe we want to make that orange. Instead of making it this, maybe we want to make it have a little bit more kind of like notice me kind of a thing here for now. We might want to say that, you know, at vid IID, right? Like, when do we make this? You know, the time is 02:21 and let's say 52, or let's just make it 22, because by the time I'm done typing it, it'll be 22. Yeah. So, that's good for me for the game camera. For the edit cam functions, we've been working on some stuff, right? We've been throwing a whole bunch of stuff in here all over the place. We're not done with this, but we want to get this stuff compiling, right? Before we stop for the day, we want to be like, hey, does it all compile, right? We don't want to leave this kind of broken. So we can, leaving the thoughts unfinished is fine, but not at the expense of making it so our project doesn't compile. So, paste AAC 2020, typical boilerplate stuff, which is not going to work. AAC 2020, typical boilerplate stuff. AAC 2020, typical boilerplate and we'll change the date here. So, 2021, 0227, and 1:26 a.m. Barg. I just like kind of making random synonyms because it's like it's like I'm doing like my own version of. Somebody said like, oh, you rolled your own GPG. And that is kind of what it is, right? It's kind of like this artificial intelligence that's like it's like a mechanical Turk, or like it's not really, it's like autocomplete overkill, right? Like I put so much autocomplete data, right? You could think of your shortcuts as autocomplete data, right? You type something and then it finds what you're looking for, right? It's an autocomplete, right? So the idea is that if I make enough of these kind of entries, these shortcuts will kind of like seem like they're intelligent when they're really not, right? So, end SSBP paste, right? So we're going to throw that in there. And that is quite a beefy kind of thing here. It would actually be nice to have some. It would be really nice to change this a bit and clean this up and make this like a boilerplate section, right? If we could make that happen. Now, if we're going to do that, we should probably do this. We try to go 1, 2, 3, 4, 5, 6, 7, right? So that everything lines up, even though, if that's really where we want to go with this, then let's do that. Because I do think that would be kind of nice. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and, we can just say, AAC 2020 typical sub it's not really a system. They're more like sub-libraries. I don't know what the difference between a subsystem and a library is, but they're definitely, some things are just like collections of data or collections of functions, so I wouldn't really call that all these things, I wouldn't call these things systems. Some of them definitely are. Some of the things over here are subsystems, but I think sub-library is more generic. So I'm thinking, I'm gonna... Sure. Game tick. Oh yeah, that's right. We made a whole game tick thing, didn't we? Game tick, we already kind of... We used that for... expiring some of our mouse objects. Let's close that. I don't think I need that open right now. So this thing, kind of like making it like this, right? To have it kind of like this section indented a little bit, I think would be helpful. And, I mean, we could keep everything capitalized like that if we really want to. So, we're going to have to keep things shorter, though. So, PF for printf, right? So we're going to have to go over here, we're going to have to define PF for printf, right? And we're going to need some more defines because this is not short enough, right? So, we'll just call it sil for silence, right? Because if we call this sil, then we can, right, silence. I mean, that's kind of ugly, but AAC 2020 silence, right? So if we see sil, it stands for, if we see sil, it stands for AAC 2020 silence. It stands for this system here. And that just makes things a little bit shorter so that we can get away with what we have here. And then this is, we already said PF for printf, so if we do that PF for printf, we don't even have to get rid of this, right? You can still keep it like this because it's not going over the border, so who cares? Yeah, sure, why not? And that's fine. I like it like that. That's fine. Now, let's save this for a second. And also, we need to... Oh, I see. If that's the way we're going to do it, then a knit none now has to... Its U32 value needs to be somewhere else. I mean, nothing else uses a U32, so we might want it like this so that we can... If it gets too big and it's no longer boilerplatey, we might want to... pull it out, right? Well, init none never does anything, so I don't know. To me, it doesn't seem like we should. I don't think it should go here, right? If that's really what we want to do, I don't think it goes here. I think that kind of violates the way we're doing things. So let's put the int32 over here, right? And then we can take it out of here, right? And now we can have a section where we undef all of this stuff, and the divisions between the sections look a little bit better, I think. So the problem with not using any templates or anything is that my code style for things is like slowly evolving over time, and then when you try to like make mass changes to things, like the style in every different area is slightly different, and that is kind of infuriating. So it's like we could refactor it, right, to make sure that it's better, but whatever. I mean, you can tell kind of like when things were written based on the kind of style of code you see in places, which is kind of cool. Also just a nuisance. But yeah, silence, U32, printf, right? So these kind of things are here. That's good. Now we haven't filled out any of this stuff yet, so let's do we really want to commit to this? I think I can commit to this. I don't think it's a problem. Right, it's because we just want to say, you know, all this stuff is kind of like usually, this is kind of all the stuff we usually have for a new system, so why not categorize it as a boilerplate section, right? So let's take this and go back to our new subsystem boilerplate, right? And once again, we're going to change our ways here and say, throw that in there. So this is the newest kind of thing we're doing. This is just an int. I guess we'll just keep it an int. Sure, why not? Sure, that's fine, Okay, so now in here, EDITCAM, we're going to have to go through all these points and use the proper case, right? So this is EDITCAM. Halt is a private function. This message here looks like it's using lowercase. This is a private function. This is capital. This is lowercase. AAC, oh, this is a public function. We can tell by this all being all capital. So this is EDITCAM, and then up here is also EDITCAM, all capital. Alright, so bam! It's all stubbed in right there. Is there more stuff we want to do? Let's look at this for a second. Snap camera to preset values. EDITCAM halt is in the boilerplate, right? I don't see anything that should be a public function yet, because we're still kind of figuring stuff out, so... oh, this is a table of data. That's why this is capital. So we're just thinking that we're just going to make the data all public, just because we don't want to hide stuff. EDITCAM, and none is public because it's going to be called by the main kind of initializer code that initializes all the systems. Okay, yeah, so editcam.f, that looks good. Editcam.d. Also, let's go into our to-do here. Polish mouse wheel zoom, right? Update. Library used to accomplish this is called editcam dot right. So this is still number 5, right, in our to-do list here. Let's also look at our agenda, right? So Okay, so we've edited our agenda. We've kind of stubbed some things in, and right now, if we try to run this, we're gonna crash because we've changed the number of this, and we need to actually get that working, right? So EDITCAM and GAMECAM need to go in here. So before I do that, I need to take a quick break, so like maybe 5 minutes, just step outside. So I'm gonna go to the break. Okay, so we're gonna get this editor camera, game camera, we're gonna get that into the system, and then we're gonna stop the stream. It's like, I don't want to do this anymore, but I want to get to like a, it's like, this is like tedious, low-hanging fruit. It's gonna take some time to do, but it's dead simple, doesn't take much thought, so it's like, we might as well, if we aren't feeling like working, we feel like we're kind of brain dead, we might as well take care of this mundane task while we're brain dead and not feeling like working, right? Because then when we are feeling like working, we can actually start solving some of the more interesting stuff rather than doing busy work, right? So that's kind of like how we are going to approach the problem. Okay. So it's right after tau sync as we're putting stuff, right? So let's go open up our library and go find libchan, which is our special kind of build system library. And in libchan top, we now have 45 systems. So we gotta go Control D, right? And now we have 44 and 45, right? So take these numbers here, 44 and 45. And then this has to match, right? So these numbers right here have to match. We can quadruple check that, be like, yep, all those numbers match, excellent. And this is just to make sure we don't go over libchan max. So then down here, right, luckily, the logical place to where we thought this stuff would go is pretty near the end of the library chain, which means that we don't have to do so much shuffling around, right? The closer stuff is tacked on to the end, the less shuffling around BS we gotta do, right? So tau sync is right here, right? So everything comes after tau sync, right? So right here is the tau sync. And so we just gotta put stuff after that, right? So we can take this and we can paste it twice. So paste and paste. And then this is the stuff that needs to be renumbered, right? So this stuff right here. Oop, not that. That didn't quite turn out how I wanted to do. So this... weird. Okay, let's not worry about that. But yeah, this stuff right here. So this thing that says tau sync is going to be EDITCAM. And this thing that says tau sync is going to be GAMECAM, right? And then let's highlight this. So tau sync is still 41, right? Tau sync is still 41, but this is 42. This is 43, right? And the systems here need 2 added to them, right? So this is 44, and this is 45. Okay, cool. So now we got to go down to our data, our function files, right? So we include all data before we include any functions to avoid artificial dependency loops. So going down here, we can find the tau sync again, right? And we're just going to take tau sync stuff and we're going to go paste it twice. So paste and paste. And then this tau sync is going to be called EDITCAM. And this tau sync here is going to be called GAMECAM. Okay. Now that we have that, we want to change these numbers, right? So these numbers right here need to be changed to 42 and 43 respectively. And then down here we have to add 2 to everything. So this is 44. And this is 45. Excellent. So after that, one thing we need to do that I just realized we didn't do is right here we're compiling up to 45. Oh, I did that. Did I already do that? How did I? At some point I did that, right? So 39, 40, 41, 42, 43, 44, 45, yeah. Yep, so right here we're already compiling up the system. I don't remember making that change. I just... some of this stuff I do still instinctively. I forget about it. So, let's... we'll just keep that there for now. And this refactor looks good to me. And then some BS down here because some pattern breaking BS where I thought it would be a good idea and got way too granular. We're going to try not to make class objects. There's just, GraQuad is just old, very old code, and so it kind of sucks. It doesn't fit the way I wrote other code. Mix stuff to hide here to avoid cognitive overload. Actually, this belongs down here, right? So this was for checking for errors. So check for errors. And it's code that's we're going to include certain headers so that we can check for problems with, we hard-coded a lot of OpenGL constants into our library, and you really shouldn't do that with internals. So I made a compromise where in this build we'll include the OpenGL headers to error check our libraries, but we won't actually directly use the OpenGL headers. And that's why we're going to include the OpenGL headers last in our project, so that we guarantee that none of the previous code can even make use of it, right? So, okay, yeah, so libchan top looks good. So in here, we need to do the same thing, so we gotta go find tau sync. So let's change the coloring here for a second. Just highlight this. This is what we're trying to focus on here, tau sync. So make that orange. Okay, so tau sync, where are you, tau sync? I know you're near the bottom. And so tau sync is right here, right? So we're going to take tau sync, we're going to highlight it orange, and then we're going to take the if, end if, we're going to copy that, and then we're going to paste it twice, paste, and then we're going to color code this differently, because we know these need to be replaced with EDITCAM and GAMECAM respectively, right? So we're going to say EDITCAM. Don't forget about this one kind of trips me up. Doesn't trip me up as much when I use token highlighting, because then I can see what I'm doing. And this is GameCam. Okay, so now that we have EDITCAM and GameCam, we're going to go down a little bit further, because, hey, look, more stuff to create redundancy to make sure we don't screw this up, right? So right here, if, and then there's an error thing. So we're going to take this one, which is still 41. We're going to go paste and paste. We're going to highlight this a different color so we can see it. And then we say, okay, 41, it's not too much. Let's not shuffle it around. Let's just manually rename it. 42, 43, 44, and 45. Easy peasy, right? Now this thing needs to be renamed, right? So this is EDITCAM, and this is GameCam. Okay. So this is very tedious, but I just find it very nice to have a... trying to hold like a very complex branching structure in your head does not work for me very well. So if I want to think about how things are actually going together, also the code doesn't even go together that way, right? If you have a branching code structure of dependencies, that's not how it's going to go together in the executable. Because a binary file is written linearly, right? Code is written linearly. Eventually, everything is put together in a definite order, right? So having a version, right? This is a version of this is a solved dependency graph, basically, right? This is one solution of my dependency graph. Is basically what it is. Yeah, having this thing here just makes it a lot easier to conceptualize the internal workings of the system and know what relies on what. So, yeah, EDITCAM and GameCam are going to be here. They're 42 and 43 respectively. And then down here, right, we see tau sync. We can go boom, boom, duplicate that twice. We'll change this to like purple or something. Oh, green. Okay. And then EDITCAM and GameCam, we can just steal these from over here. And then we can paste these over here. And then we see 41, let's just manually rename that, 42, 43, 44, and 45. 45 systems. So this is crazy. I have 45 systems, and I still don't even have the basic editor finished yet. But I think I have a very solid code base, so I'm not going to fret over that. Okay, so now that we have libchan taken care of, let's go look at F macros. So F macros. So in F macros, we have init none functions, right? They should both have init none functions. If they don't, we need to address that right now. So let's look at EDITCAM for a second. It has an init none, excellent. Okay, well, what about the game, whatever the heck, right? So, GameCam functions. Do you have a init none in here? Yes, we do. Now, it's not written the... Let's do that boilerplatey stuff. Let's keep the boilerplatey stuff. So we thought that, you know, it'd be nice to... let's look at EDITCAM for a second, right? So, let's steal these kind of headers here and kind of shim this together, right? So, take this from here. And then down here we have this stuff. Let's take that from there. Let's try to use this as our new standard for this kind of stuff. Right, so it's a whole bunch of boilerplate. Not auto-generated, just cut and pasted. And this thing is SIL for silence, right? So SIL for silence. To keep it shorter, right, so that we can fit it all in one thing here. And then this thing right here, anywhere where we see printf, we just want to do pf for printf, right, because we have macro for that. And once we do all that, everything kind of fits where it needs to be. The U32 though, we can remove that from here, right? So we're going to remove that from here. Okay. So, GameCam, let's make sure that GameCam is everywhere we think it should be. GameCam init none, GameCam here. GameCam, I don't know why it didn't highlight when I... GameCam, lowercase, namespace. Okay, that looks good to me. GameCam is not something we're going to look at for quite a while, so let's just close that. Okay, so fmacros top. We just need a init none function for this. And for this, I'm getting tired of rebuilding this because we have to delete everything and then painstakingly edit the spacing and whatnot. For now, what we're going to do is we're going to try to be very careful about how we're rebuilding this. We're going to edit it by hand, but also keep this list here for auto-generating things, which is kind of like... That may lead to horrible, horrible problems in the future, but... it makes it easy on us for now because we don't have to... Makes it easy on us for now because we don't have to do as much work to get this in here, right? So we got to look for wherever tau sync is, and we're going to add these two things after that, right? So we're going to go through here, right? All this very repetitive, redundant code, and we found the thing we're looking for. And we're going to go paste and paste, and then we're going to color code this a different color, say like a blue. And that kind of is a little bit too ostentatious. But I know where I am, so I think I'll be fine, right? So any of these things that say tau sync are EDITCAM here, in this particular section. Okay, EDITCAM. And then down here is GameCam, right? So this one is GameCam. Okay, so now that we have done that, we're going to get rid of the token highlighting, and then we're going to make sure that everything is compartmentalized where it should be, right? So, right... When we highlight these three different colors, we should see three distinct sections of colors, and we shouldn't see any interlacing at all, right? Just to visually check that was done properly, right? Then all this stuff, don't have to worry about that. It's for the other initializer code, the init function, rather than the init none function. We either have an init or an init none in our code for a certain system. We're not going to update this. I'm sick of updating this, right? And I say not guaranteed to be up to date, so maybe we can say, you know, not yeah, it's not guaranteed to be up to date, and I'm fine with that. 1, 2, 3, 4. We're just gonna make that orange just so that it kind of stands out, and then, you know, actually let's make it red. Let's make it more of a. How does that work? Red is harder to see than orange or yellow, but red psychologically is more visible. Red on the spectrum of colors is less visually blatant. It's less visually in your face. Like from up here, if you analyze it from like, if you just look at the intensity of orange and yellow, they are easier to spot in terms of just the color being easier to spot. But from a psychological perspective, red is more likely to get your attention. So red is more likely to get your attention than orange, even though orange is more like flashy. Does that make any sense, right? So anyways, right, that's why a stop sign is red, not orange or yellow, even though orange and yellow stand out more than red. If that makes sense, right? Because red is the color of blood and evolution, genetics, blah, blah, blah. Okay, so bottom file. So we merged our init and our init none section together so that we could create like a checksum of all the systems here. So we could make sure that everything's accounted for, right? And so we have some things that do not have any systems for them, but now we can easily see what's not accounted for here that doesn't have any code. We can see what has the init nones, and we can see what has the inits, right? So we have a little overview. We have like a subsystems overview, sublibraries overview kind of going on here, right? But this is just designed so that we can not pollute other people's code, right? So we want to make it so that if somebody uses our library, we don't pollute their code with a whole bunch of macros. Besides that, just leading to some disastrous problems if they want to use a certain name. I think there could also be a performance impact from polluting a preprocessor with a whole bunch of macros, you know? So if you're not going to use the macros, get rid of them, right? Don't pollute other people's macro preprocessor space, right? So EDITCAM, GAMECAM, Paint 5D, etc. 41, 42, 43, 41, 42, 43. Good, okay. So that's good. Now we have to go into the functions file now. So we've worked on F macros, but now we need to go into main. And we've added this stuff here, which I don't even know. I believe this is like a functions file, and this is a data file, but this is the actual entry point, right? Entry point, and then the data is also... Things are a little bit wonky, but these are the basically master top-level most-ish files. And so the more top-level you are, the shorter name you get, because you're more frequently used. Okay. So in here, we know that this code absolutely comes after the window code, right? So we have two sections of initialization. We have one chunk of initialization in main that is coming before the window gets set up. And then there's other systems that kind of are going to rely on the window existing. And that's this stuff here. So here's our tau sync. Okay, right there. So let's go duplicate, duplicate. and change these two. So we're going to say copy this, copy that, and we're going to go, bam, paste that in there. Okay, so now we got tau sync should be, I already see a problem here that I just kind of like threw this in here, but I'm seeing that we are missing something here. So tau sync should be 41, 42, 43, 44, and 45. Tau sync should be 41, right? Tau type, right, should be 40. Right, all these numbers are off. Where is it correct? Like, what do we add in here that that screwed everything up? So 17. Let's just go look at 17 for a second. 17. Native DUI, right? Native Dialog User Interface is 17. And we can see here that we have GL bind instead. So we're going to duplicate that, and we're going to make this 17, right? And then we're going to push everything up here, right? So tau type is 40, right? So we're going to go all the way down to, we're going to go here to 39. Go up. And then this is 40. 40, 41, 42, 43, 44, 45. Excellent. Then we can change this over here. So it looks like we have GL bind init. Oh, actually we screwed that up, right? So this needs to be native DUI init. I don't even know if it has an init none function or whatnot. Let's go look at that. So native DUI, do we add like an init none function to it, or what's up here? Halt. I don't think I see a init none. Hold on. I don't think there is one. Hold on. Well, since we're here, kind of refactoring stuff, why the heck not? So, paste init. So here is a basic init none function, right? And this is going to be a native DUI init none, right? So if we look for underscore init, let's make absolutely sure that there's nothing in here that's like init or whatever. Init. Yeah, there's nothing. Oh, actually, don't match case. Yep, so this init none that we just stubbed in here is correct. That does mean that we're going to have to potentially change some things around. But native DUI is 17, and it comes before the GL bind. So native DUI, and all these numbers are good, except, hold on, this is init none. Okay, and then EDITCAM and GAMECAM are init nones as well. So let's just duplicate this, right? And it comes before GL bind, right? So that's native DUI for native DUI, and it's going to be init none function, and init none function gets a 0. Why? Just so I can visually see the difference in this column easier. That's the only reason why. So now, as we're shuffling things up, tau sync, tau type stays at 40, or tau sync. Let's just nuke this for a second. Make this easier to follow. Alright, so tau type is 40, right? Tau type 40, yep. And then tau sync is 41. And then we want to duplicate. And then we have EDITCAM and GAMECAM. And those both have init none functions. This is a init none function here. EDITCAM 42, 43, 44, and 45. Okay. So does native DUI exist within the silent system? I don't think it has anything, but is native DUI in here? Yeah, native DUI is in here. EDITCAM and GAMECAM is in here. Okay, cool, that's good. So that looks good to me here. But also, we need to go into F macros because I'm going to take a guess that native DUI init none does not exist in here. I am pretty damn sure, actually. So these are the init none functions. And if we look through here, we have to find kind of relatively where this belongs, right? So native key is over here. So native key, it's somewhere below native key, right? So native key is here. iKey lists maybe too far. No? Hold on here. Native key. iKey lists and iKey CMD are just not in here. Are they not in here? Okay, let's go compare this to... Let's go put this on this side for a second. iKey lists. Keybind is here. C editor is there, but we don't have... We're going to put question marks here because we don't know. But we're going to take iKey lists because we see that's not accounted for in here. I'm going to assume it's not, because if we were trying to reference it from iKey list, then if we were trying to reference it from iKey list before, it would have complained if we actually had that code there. So I'm going to say underscore it's a no, right? So then let's go look for iKeybind and add iKey list and iKey CMD in here. So right here, we're going to add... These things do not exist yet because these are to do hidden console stuff, right? So that's what this is for. This is for creating a, this is for helping me create kind of a hidden console, I believe, right? So there are some Yagni kind of things in here. It's like you aren't going to need it, and I just put it in here anyways because I thought it'd be good for later. Like a lot of things that are nice to haves that I really kind of feel strongly about, I've kind of like stubbed in here in certain places where I think they belong, which could come to bite me if I forget about them and then rewrite the code eventually when I need it. But yeah, this will turn it on, even though it doesn't really exist yet. And we'll keep it as like a little underscore here for not being checked off yet. Okay, so then, let's go look at those, right? So let's go, oh boy, we're just all over the place, aren't we? So so we're gonna need some F macros for that. Yeah, but wait, there's more. So ikey list and ikey CMD. Let's go find those and see what's up with that. So ikey list function, and then ikey CMD. Okay. It has an init none, and this has an init none. So they're both stubbed in there, so that's good. And that just means that... Do we just stub this in here, or did it exist already? ikey list and ikey CMD are already in here. But their order isn't quite right, is it? Init none functions. Okay, so that's already in there. Now, is it in the functions file, though? It might be. It's before... GenaWin is here. It's before GenaWin. If you want to get to ikey list, it is before GenaWin. If we want to get that in here, then we're gonna have to put some other stuff. Great, now we're all over the place. I mean, we can do it. So native key is right here. That's a big bullet to take, right? So iKeybox, iMouseBox, all these things. 10, 11, 12, right? So putting all these things in here, right? Sure, why not bite the bullet and just get this over with? 1, 2, 3, 4, 5, 6. So we have 6 things that are going to be in here. So, Controls do. Okay, so after native key, we're going 1, 2, 3, 4, 5, 6, right? And we're going to take all this stuff here. Right? And none of these things should have anything referencing them yet. Oh, right. Oh, ikey list is here. ikey CMD is here. C-editor is here. C-editor, none, is that in here as well? Nope. And C-editor is before GenaWin, so that would be where it would go. If, so we're gonna, right, we have a missing init nuns. We're gonna get rid of the missing init nuns, and we're gonna just make sure that they all exist. So native key is 9, right? So this is 9. This is 10. This is 11. This is 12. This is 13. This is 14. This is 15. So is C-editor 15? C-editor indeed is 15. iMouseBox is at 11. Yep. How iKeyless is that 13? Yeah, iKeyless is 13. 14 ikey CMD. Yeah, so those are all correct. And we're going to do the same thing here. So 1, 2, 3, 4, 5, 6. 6 things after native key. So we're going to take this and go 1, 2, 3, 4, 5, 6. And then we're going to steal all this stuff. Copy that. We're going to paste it right here. And now we have these two accounted for now, so we're going to take that out. And then we're going to steal this checksum, because that should be the exact checksum of this, right? So we should be able to just go bam, paste that there. And now we have some trouble on our hands, because we got a lot of stuff that between here that needs to make sure we have like init none functions for. So we're like digging ourselves into like holes here all over the place. Let's go look at EDITCAM and GAMECAM though before we look down there. So EDITCAM and GAMECAM are in the Control F help here, and then EDITCAM and GAMECAM are here. So that's good. But we have to, if we've made these F macros, we got to make sure those are accounted for, these new F macros. So init and init none. This is the bottom file, but we can start here. And we had some things that were not accounted for, right? So in here, it should be between this thing here. So native key and then iKeybox, iMouseBox, keybind. These things were here, and then cEditor. GenuIn, and then native DUI. Oh, so native DUI. Let's make sure that that is in the function file. So if we go here and we go nat DUI init none, let's make absolutely sure that's accounted for. So it's not accounted for. Let's go look for nat DUI for a second. Not accounted for. Okay, so let's go find the init none functions for a second and see where native DUI is coming into play here. Nat DUI is right after GenuIn, and because of that, it doesn't go in this first section. It actually goes in the second section. So, that's troublesome. What were we searching for? Nat... Oh, because it's not nat DUI, it's native DUI, right? Yes, it's native DUI. And here it is actually happening right before glbind, which in fact is where it belongs. Okay, so we need to look at, so we got native key, and iKeybox needs to have something now. And iMouseBox needs something as well. And then iKeybind, or keybind needs something. Or keybind, no, I think keybind does not have any initializer code as far as I'm concerned, or as far as I know. iKeyless, iKeyCMD, and this is cEditor, current editor, right? So cEditor. Okay, so if we do this, let's go look for let's go make sure that iKeybox, iMouseBox, and keybind actually have those things. So iKeybox. So you got init none. So there is an init none function here, huh? Okay. iMouseBox. Do we have an init none function here as well? We do. We've stubbed one in there as well. How about keybind? Do we have an init none? Okay, so we're just going to paste an init none function in here. iKeybind is just like doesn't really have any stuff in it. It's not supposed to be a function file. It's not supposed to be a function. It's mainly a data. Oh, hey, I just saw. Sorry, I was looking down here. I will get to your. Hold on. So this is keybind, init none. Yeah, sorry, just saw, I don't know when you sent that. It's like I see things, I have it on the other monitor, and then I'm like focusing, so I'm like, hi, sometimes. I'm doing good. Just doing some mindless refactoring, time-consuming stuff. Busy work. Feel like working and... Yeah, so I don't know when you sent that, because I can't, here, let's go in here and say, let me put this on the other monitor before I whisper to you. So, let's see. Just gonna call you Jink from now on because I don't know how to pronounce your name, and if I remember, you don't even know how to pronounce it either, if I remember correctly. Jink Week. Up, but just saw in chat. Well, okay. Anyways, so I'll try to look at this if. Oh yeah, you don't. Jink works fine. Okay, cool. Okay, so you are here. Yeah. So I'm just working on some mindless kind of refactoring stuff where it's there's just some loose ends that needed to be tied up, and so. It's one of those things where, as I was doing, I was stubbing in some systems. So, the new systems I'm stubbing in are EDITCAM and GAMECAM. And it's not object-oriented programming that I'm doing. So, don't think of this as some type of camera that's for an editor, and this is some type of camera that's for the game. It is actually, these are... editor camera friendly transformations, and these are game camera friendly transformations. So inside of this thing called tau type, it has transformations that modify a camera rectangle. So in here there are certain transformations in tau type that are used to just transform an inclusive rectangle type. And I use an inclusive rectangle as my camera, right? So if you sub-select over a data set, and you take a very small selection of that data set, you're zooming in. And if you take a very big selection rectangle, you're zooming out. So when I say a data set, well, say a tile map. If we take a very small sub-selector rectangle over a tile map and map that to the screen, we're zooming in, right? And if we take a very big rectangle around the tile map data and we map that to screen, then we're zooming out. This right here is just, this is transformations that are built on top of the basic transformations. It's like one layer of abstraction removed from the basic rectangle transformations, and it's just things to make the camera work in a more user-friendly way for the editor. Same thing with game camera, like if we need code to help make the camera like follow the player or that kind of stuff, then we'll need a section dedicated to those kind of polished transformations, right? So, but this stuff right here is going to be built on top of this stuff, which is kind of hard to notice because it's just called tau type. and it's not like rectangle type, right? Because it's just like tau type is a whole bunch of types that they exist. They don't actually exist anywhere. They just exist within the pixels that are stored on the texture, right? So you take a few pixels on the texture, and you just say, hey, these pixels are going to be this kind of type. So these functions in tau type basically say, hey, these pixels here, just trust me that these pixels are a rectangle, and now go transform that rectangle, right? Or these pixels are actually an auto tile set value. Go make it store the next auto tile set value, right? Increment or decrement it, right? So it's kind of weird, but that's the way I've been doing the code. So, but anyway, so I was stubbing in these two systems here, and while I was doing that, I was like, hey, I have some missing things in my code where there are certain systems that don't do anything function-wise, right? They're mostly data-only kind of systems. But even if they're data-only systems, I want them to have what's called an init none function. So init none here. And an init none function is just there to function as like a roll call. So when I'm initializing all the systems, I can call the init function or I can call the init none function. And I'm starting to lose my place because I got all these loose ends. So we're trying our best to stub everything in correctly. So right after native key, I need to look for iKeybox, iMouseBox, and keybind to make sure those have a init none function. So if we look at iKeybox, I don't see it in here. If we look at iMouseBox, we don't see it in here. We don't see it in any code, right? Now, if we look at native key, right, we should find an init none function stubbed in here. Okay, so we're going to steal this here, right? And we're just going to paste and paste, and actually paste 3 times. And then we're going to color this some other color, maybe like a green or something. Or I guess it's purple, my bad. And we're going to stub in these functions here by hand rather than auto-generate it, because I thought this would be faster, but now I kind of regret my choice. I changed my mind on that. We're not going to stub in this manually. We're just going to rebuild the list. Yeah, we're doing too much manual editing of this. We're just going to rebuild the list and hope that the list is correct and that we're not missing anything. So we're going to take this section. All this code is auto-generated. And we're going to nuke all that code. And we're going to hope that this list is correctly changed. So we have ceditor in here now as well. So yeah, we're just going to take all this code here, this auto-generation code, and yeah, we're going to take all this right here, here to here, source code, copy, and we're just going to go find and replace clone to paste it all in there, and then we're going to clean up our spacing, though I'm kind of getting sick of this. But I don't want to rewrite my code that does this because it's written in AutoHotkey and I hate AutoHotkey code. So it's very painful to edit AutoHotkey code. Like if you think C is hard, go try editing AutoHotkey code and then realize how awesome C code is compared to AutoHotkey. But yeah, some mindless kind of like stuff here. I really should just change my script to get rid of these extra spaces, but I don't really see any need for all this extra space, so that's kind of why I take the time to clean that up. Okay, so I think I think some things are gonna blow up in my face now, and let's figure out what blows up in my face, because I don't want to stop the stream until I have the code compiling again. So okay, so unknown type name I32. It's coming from my my EDITCAM code. So that's better than coming from my build system kind of code. Well, we'll see how this goes. So inside here, yeah, we got this I32. We got tab for table, and the table is this table here. Okay, sure. So we'll just define int32 up here, and we'll undefine it here. And then down here, it looks like we already have that kind of there. While we're here, we might as well just make little checksums, because I'm all about making checksums for some reason. Could be like just liking to count, honestly. Right, so the idea is, what do you call it? Like, you know, like I don't know, different households have different rules, but in my household, we have this, like, rule about, like, you know, if you go into the kitchen, you should be leaving the kitchen, as it was, as you found it, or you should leave it better than you found it, right? So I kind of have that philosophy with my code, where it's like, after I fixed it, I want to also kind of leave it better than I found it, right? So I find a problem with the code, I fix the problem with the code, and then I look at the code and be like, hey, there's a few things that could look a little bit better. Let's clean some things up a little bit. Now, what is cleaning up code? Well, that is kind of subjective, because the kind of batshit crazy way I do things, you might not think that is cleaning up code. You might think that is just turning this into an extra disaster, but to me, I think it is cleaning up the code. So, but yeah, we're just going to keep these nice checksums here, so that, really, a checksum of 2 doesn't really matter, right? I mean, we can tell this is 2 things. But as the lists grow over time, that will be more important to number. So I figure just get to it now, just to make all of my section dividers more consistent. And unknown type name, actually it's pointing at the close comment. Well, no, it says I32 here. EDITCAM, oh, this is EDITCAM functions. We need to go into EDITCAM data for a second. So I was looking at the wrong file. And, oh boy, a lot of stuff in here. Oh, actually, it's not a lot of stuff. It's just like a whole bunch of commentary, right? So, anyways, so in EDITCAM, we got camera zoom, polish data. And then some int32 here. Camera zoom, polish data. Okay, yeah. So in here, it looks like we're using int32s for this stuff. So we just need to, at the beginning of this section, we need to define what an int32 is. And since we've been numbering everything else, we might as well just number this, even though there's not really much in here, but there's only one, a checksum of 1, which is kind of bogus, but... And then down here, we're just going to say, you know, undef int32. And then... Yeah, okay, yeah. So, give that another run, and like I said, I'm just trying to get stuff running again. Because I'm just trying to stub in some systems, so this could take a... blah blah blah, it doesn't allow extra blah blah blah. So right here I have this habit of doing double semicolons, and I can't do that with pedantic mode on. Basically, if an expression spans more than one line, I like to put double semicolons at the end of its scope. It's just a little redundancy that I do in my code, so that if I accidentally delete a single character in my code, I'm more likely to detect doing that. It's just a paranoid thing, honestly. And it's just a weird oddity in my code. Like, you know, you can look at my code and see the weird things I do, and you can tell that it's my code, which is kind of cool, I think. Unknown type name, IO8. Though, actually, I think my brother says, like, when you're working on a team, the idea is you want to conform to a standard so that, ideally, no one should know who wrote what code. When they're just looking at the code, because stylistically, right, everything should just conform to a certain way, a certain standard, so that you can't tell who wrote the code, right? And you know what, I kind of agree with that. I agree with that. That makes sense, right? You want your code base to be as uniform as possible, as regular as possible. So that means that if someone else is working on this project, right, if someone else is working on my code base, I would want them to write it in this same batshit crazy style that I use, right? And if I was working on a team where people wrote their code in a more normal way, I would write my code in their standard, right? And use their way of writing code, right? So I would tone back the craziness. This is not finished, so let's just say we're just gonna make a note here, just in case I miss this while I'm, all over the place. Since I know that list, I see blatantly that this list is not finished. So and this can go off the border because it's a to-do message. To-do messages can go off the right-hand side just because they're allowed to annoy me. So yeah, there's an IO8 somewhere in here, like a 8-bit integer, and I don't think it's in this file. It's in the function file, right? We're in the data file. If we go into let's close that. If we go into the, let's close, maybe not close this. So we're assuming that these macros exist now. Oh boy, we're all over the place. Let's, I am all over the place. This is, it's like I don't recommend being all over the place like I am right now. But it's like, this is busy work that needs to be done. So as I was doing the busy work that needed to be done, I saw more mindless busy work that needed to be done. But the thing is, if you tackle a whole bunch of busy work that needs to be done all at the same time in a unstructured way, it starts to not be that much of busy work. It begins to be a lot harder than it should be. And I would not recommend doing what I'm doing. Now, I think that there is some goodness in knowing when you're doing something dangerous in your code, where it's like, I know I'm all over the place, I know I'm doing something dangerous. Knowing the amount of risk you're putting on your code base, I think, is important. So yeah, let's just go look for this. So iKeybox, native key, iKeybox, iMouseBox, and keybind. They're already over here, right? So we're going to assume, right? And the thing is, this offers some redundancy too, right? Because if these undefs end up not working, right, you can't undef something that doesn't exist. So if by any chance the compiler complains about what I'm doing right now, it's a little redundancy to help me realize that I forgot something, right? So we're about to test how well these redundancies in our code are going to help us. So we're going to undef this now, and we're going to undef this. So we kind of put those as placeholders so that we could see what we're missing in this kind of master list here. Okay, so we have 1 to 45, and if we look at, let's close this. If we look at our master kind of like list of systems here, like our master, you could kind of think of this as a build file. It's not really a build file, but I don't really have, well, I have a build script, but a lot of the build script-ish kind of logic you'd expect in a build script is actually kind of like in the C source code itself. So you could think of this as a build system if you wanted to. And this is like how all of these systems go together in the exact order that they go together. I think I've been over this, but maybe you haven't heard it before. This list basically here is it is one solution to solving a dependency graph, right? So the idea is that if I manually solve the dependency graph like this, then I have a lot of more certainty of how all the code is being put together. Okay, so we don't know where we are again. Oh yeah, so EDITCAM.f. We gotta go look at this for a second. And we got int 32s, but then somewhere we had an 8-bit integer. I think it was in here, because found we made an 8-bit integer, because we were like, hey, we don't really need 2 bits for this, because it's just a flag, so why are we wasting that? Let's just do that, right? So then over here, let's just say, you know, define, define, let's use our shortcut for this, right? Let's not have to type it all out again. So int 8 type from the GCC std int header. And then we can highlight this to jump down to the bottom of our sections. And we're just going to say IO8. And this is the third thing. Tab I32 and IO8, right? Or tab I32 and IO8, my bad. Okay, so now let's just give this another run and see if we can get this, kind of... Yeah, 1 equals 1. Yeah, that was supposed to be a double equals. Yeah, so infinite loop, and this list we have, this table here, we decided to make it a null terminated list, meaning that the last entry is 0. And so rather than looking for how large the list is and doing a for loop over it, we just look for a 0. Right, once you find a 0, we know we found the end. However, this dex, this algorithm wasn't completely finished, right? Because dex needs to be put in here, right? So dex needs to start at, like, let's just do int 32 dex. And this is going to equal 0 minus 1. Specifically 0 minus 1 for reasons that will be kind of clear once we, let's line this up. So 0 minus 1 here, and the reason for that is so that at the very beginning, I like my increment logic at the top of a loop. So doing that means that the first used value equals 0, right? So I also like to make sure that I know what I want to explain what this is. And I say the first used value is 0, right? So that's saying that the reason why we set this to -1 is so that this plus plus makes it go to 0, right? So sometimes it can be very tricky kind of figuring out how to set up your code correctly to enter the loop and then set up your code correctly for, like, getting out of the loop. So, like it'd be like to make an analogy, it'd be like, let's say there's like there's a giant spinning hamster wheel that you have to get into, right? And the process for how to keep on looping once you're in there is pretty straightforward, right? But the setup code is hard, right? Because you gotta, like, figure out how you're gonna run and jump into this gigantic wheel and start running, right? And then after you're done running, right, so the running part, that's easy, but after you're done running, you gotta figure out how you're gonna, like, jump out of this giant hamster wheel, right? A lot of looping code can be very similar to that, where, you know exactly what you need to do in the loop, but getting it just right in terms of entering and exiting the loop can be quite an art form, and it's like, you don't think it should be that hard, but a lot of times it is much more effort than you think it would be. Index or tab dex. So let's just make a comment based on its usage. Okay, so now you might see that there's dex plus 1 and dex 0, right? So as we're going through here, to make sure we don't do any seg faulting, you'll notice that the bailout condition is looking for dex plus 1, right? Because dex plus 1 is always ahead of this. So this access pattern here would be the first thing to seg fault on us, right? So we want to look ahead with this one and make sure we haven't hit that null terminator in our list. If we have, we're going to break out of the loop, right? That's the only thing that's going to get us out of this loop. Actually, if it's found, we should probably also break out of the loop as well, right? So the first time we find something where the lower bound, the camera is less than or equal to this lower bound, and the camera is greater than or equal to the, less than or equal to the upper bound, and greater than or equal to the lower bound. So this list goes from, this is up bound / high bound. Let's just call it up bow, high bound, down bow, and low bow. Let's not do that. Upper bound, lower bound. There. Okay, that commentary makes a little bit more sense. Let's not be too cryptic with our comments here if we have enough room to not be. Let's change that a bit, make that a little bit better. Okay, yeah, so this is the upper bound. We want to be less than the upper bound, less than or equal to the upper bound, and greater than or equal to the lower bound. And so what is that all about, though? So, if we look at this thing here, it's looking at this master list here, and it's trying to figure out. You can see this progression of camera sizes. So a 512 by 512 camera selection region, a 448 by 448, 128 by 128, 24 by 24, 8 by 8, etc. And so in order to make the camera zooming a little bit more friendly, we're going to try to snap to all these values. So the code here is just navigating. Is taking a value, it's taking some type of camera size, and it's trying to snap it to the closest value that it can find. So this output span uses this function to find what to snap to, and I don't think I actually wrote this code yet. So we're going to take this function, which should return an int32, and we're going to write that now. Snap camera to nearest power of 2. Camera snap helper functions. Camera snap helper functions, right? And that's what I'm going to call this section here. Make sure that these categories, these labels, nope, because I called this funcs. Okay, there we go. So in here, it's going to return an int32, and the easy thing with this is we don't have to try very hard to remember what the variable names are, because the way we name the function, right? It's the camera span, right? And then we're going to input the, we're going to take int32 min san, and then we're going to take an int32 max san. So max span and min span, right? And we want to snap to whichever one of those is closest. Okay. Let's just define int32 down here. And then define it, undef it here. I think I have a shortcut for undeffing, yeah. Okay, so the easy way to do this is we just want to say int32 min delta equals it should be between the min and the max, right? So cam san minus the min san, right? Because it should be bigger than the min, right? And then int32 max delta equals max san minus cam san. And let's just do some asserts here, right? So we want to assert that min san is greater than or equal to max san. Assert that cam san, camera span, right? Want to assert that the camera span is greater than or equal to min san. We want to assert that cam san is less than or equal to max san. Okay. And that's a lot of asserts, but that's basically if everything is if it's being used correctly, then that's the case of what should be happening here. Okay, so after we have these deltas, we can also assert, to make absolutely sure, that min delta is greater than or equal to 0, and assert that the max delta is greater than or equal to 0, right? So they should never go negative. These asserts here, should get triggered first, right? Like, this should never happen, right? Because by the time we would have these calculations yield something that was negative, these asserts would catch it. But it's nice to have extra redundancies here. So, if we wrote these asserts wrong for some reason, this can also catch the problem. Okay, so now we have these values, and we're just going to say, we're just going to pick whatever is biggest, right? So if, or sorry, whatever is smallest. So if min delta is less than max delta, right? If the minimum delta is less than the max delta, then we just say that the outspan equals min delta. Right? And else, so you do an else, yes. If, let's just do an else so that we don't accidentally get the problem with the equal case. Like if we do less than here, if we do a less than comparison and then we do a greater than comparison, the case where the minimum delta is equal to the maximum delta will create some problems for us. So if the minimum delta is the smallest value, right? If the minimum delta is the smallest, then we'll take minimum delta. Else, it's either greater than or equal to, we'll take the max delta, right? So, snap to whatever you are closest to. Okay. And then right here, we're going to return that. So we're going to return the output span. And then right here, we're going to say int32 outsan for output span. And while we're here, we might as well just make some more shortcuts for this stuff. So, outsan. Do we have a thing for that? No, we don't. So, outsan is the thing, bones, hexa, baseline. If we type it like this, then we want to correct ourselves. Okay. Now, if we do it backwards, we're going to say san out, and san out. Backwards, use, and say outsan. And then, also, what the heck do we mean by that, right? So, it's kind of a cryptic kind of thing here. So, outsan and outsan. So, outsan is output span. Span. Width. So when I say span, I mean width equals height. So instead of passing around some width variable somewhere and a height variable, all the things I do usually have a rectangle where the width is always equal to the height, right? A square, right? And so rather than just always passing around two variables where the variables basically always need to be the exact same value, I just use a variable called SAN, which stands for span, and that's when the width equals the height. What else do we got in here? We got like min-san, etc. Min-san. So, min-san, max-san. Let's just take this, right? Farc template. Because I think what we can do is we can just steal this code here. And we can put it in here. And then we're going to look for out, right? And we're going to place out with min, max, and we also have cam-san. Yeah, we're just going to replace it with all these, right? Min, max, and cam. So we're going to take that, and then we're going to run farc. And farc creates these for us, right? So we got min-san, we got san-min. These are backwards, right? Min-san, min-san. Now we have to change this, right? So min-put doesn't really make sense, does it? Minimum span, right? So that definition looks good to me now. How about this one? Max put span? No. Maximum span. Span is where width equals height. Cam-san is camera span. But cam put span. So we're just going to say camera span. Excellent. And we also already have the backwards versions of these here. So that's nice. Okay. So are there any other variable names that we feel like documenting at this point in our shortcuts? Well, we have max delta and min delta. So max delta, do we have a thing for that? Nope. Do we have a del max? Nope. Do we have a min delta already? Nope. Do we have a max delta? Nope, we don't. Okay. So we're going to take if we take this, min and delta, right? So, farc template. If we take san and convert it to delta, we'll get what we need, right? So we're going to look for san, and we're going to turn it into del for delta. Right? And now we have minimum delta, and then we have del min, we have the backwards. And then all we have to do is say, minimum del delta, right? And now that we have this, we can take this, and we can do farc again. Or, sorry, not... Oh, God, that wasn't the thing I wanted to do. We wanted to do a farc template. We want to take this source code. That's minimum delta. And we just want to take min, and we want to search for max. And if we do that, we'll have all that stuff. So run farc on this. And now we have max delta, and then we have the opposite, the backwards ones and the corrections. And then maximum delta, that's already pretty close. Let's just say maximum delta. Alright, cool. So now we have documented a whole bunch of variable names. It's like a lot of busy work, right? But it's nice to have that kind of stuff here. So, So we're just gonna make a section divider for all this kind of stuff we added. And now we're going to, what are we going to do now? I guess we're going to make sure we're going to try to compile again and see what else we're missing. And yeah, we're going to keep on going until we can get this compiling. So, well, that's a bad thing. We have a hashtag undef whatever, and that's in right here. So that was stupid of me. Well, we're here. Let's leave it better than we found it. So let's go over here, make a little O1 here. Right, it's a checksum of 1, which is kind of ridiculous to take the time to do, but I want to leave the code better than I found it. So I fixed a problem, and now let's leave the code even better. Okay, so now let's give that a roll and see if we have any other problems. Okay, yeah, so we kind of shuffled everything around, and one of our static asserts failed in F macro's top, which I'm not surprised at all. So, F macro's top. So we look at this file here. I forgot this stuff here. So 42. So if we go down to... let's put this on my other screen again. If you look at this library chain, we've made an insertion. We've made a lot of insertions. We better check a lot of numbers, right? Anything that comes after 9 is suspect. So CPU info, right? So 20. Okay, that's still 20. Okay, that's good. Graquad, is that still 21? Yeah, that's still 21. Yeah, because we didn't make any insertions here. We just were messing with the... Okay, 39 is suspect, though. So 39 is Tau Depot. 39 here is Tau Depot. Okay, that's good. 41 is that Tau Sync. 41 is Tau Sync. And then right here is where we change things. So anything after here got shifted down, right? So Paint 5D is not 42 anymore. Paint 5D is now system number 44. So we gotta go 44 and 44. Now, it may seem kind of pointless to have that kind of thing there, but that kind of redundancy is really going to save my butt when I make like large refactors of everything like this and start putting things in the wrong order. So iMouseBox implicit declaration of function iMouseBox init none. So we just got to go into the iMouseBox function file for a second. So iMouseBox functions, and there's probably not an init none function in there, right? So make sure it's not open over here. And yeah, so it doesn't talk, right? It doesn't actually have any code. And then this is Maubox, which is 6 letters, so I know this is incorrect. Also, the file name is iMouseBox, so we were pretty close, but we did not name that correctly. So that wasn't the mistake I thought I was going to find, but yeah, so we're just doing a whole bunch of stuff that kind of sucks. That's what we're doing. Native DUI, init none, F macros, implicit declaration of function. Okay, so it's saying that F macros function doesn't exist. Okay. So let's go look in F macros first, I guess. So F macros. And let's go look in the top file. And it's our init none functions, right? So here's my init none functions. And a native DUI, right? So I thought that was at the top somewhere. So it's only showing up here. Yeah, like I said, we were all over the place. So this is our init none functions, and let's go make sure we insert this kind of where it makes sense. So native DUI is 17. It comes after GenuWin. GLBind, cEditor. So here's cEditor, right? And after cEditor, there's GenuWin. So it should go here, right? So, native DUI, right? So, because we have ceditor, GNOWIN, and then native DUI, and then CPU uniforms right here, CPU uniforms right here. So what we're going to do is we're going to go look for ceditor, and we're going to put the native DUI code right after that. So here's ceditor. We're going to copy this, and we're going to paste it, and we're going to say that this right here, all of these things are going to be changed to native DUI. So native DUI, copy that, paste that in there. Okay. And now we'll give that another run. And hopefully, eventually, I just want... Okay, there we go. Okay, so... Okay, cool, 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 cool. And then over here... Okay, cool. Yep. Yep. Okay, memory viewer. Okay, very cool. So we got this auto tile set editor thingy, and we have that. And if we type, it's X takes smaller tiles, so we can do this. And we can try to draw something, right? We can do this. It's a very pale color that makes things very hard to see. We can do this. We can zoom in. We can also pan with I, J, K, and L, which requires me to use the other hand, which is kind of annoying. Because the idea is to do everything on... Keep one hand on the keyboard, one hand on the mouse, which the I, J, K, and L panning does not do. And we're going to fix that by just making the mouse be able to pan. Okay, so now we're going to do P for pattern, and then we're going to do search to this kind of stuff and say, hey, look, we got a thing, right? And then, you know, we can zoom in and out, and zoom needs to be fixed, because like I said, it's very slow right now, right? Like when you're all the way out here, you zoom in by 1 pixel, 1 pixel's worth of data, and it goes very slowly, right? And then as you get zoomed in further and further, it starts to move faster and faster. But visually, it looks like you're moving faster here. I'm actually moving at the same speed. Because this is 1 pixel right here. 1 pixel has gotten a lot bigger, so when you move the viewport, when you make the viewport bigger by 1 pixel, right, as the pixels get smaller and smaller, you appear to move slower and slower. So yeah, we just want to fix that, because that's kind of just, you know, meh. And then, hey, look, we can put some stuff down here. See that? Cool. Boom, boom, boom. Right? So yeah. We're done for today, I think. We've kind of like mucked around, cleaned some stuff up. We got a lot of stuff to do. Let's go make sure the agenda looks correct. So if we look at the agenda... So before we get out of here, we have to commit, right? So let's take our code. Well, I don't know why I did that. I guess, well, now we're double checking to make sure it still runs, I guess. So I guess that's cool, but that's not what I meant to do. Okay, cool. So that's that. Okay, so clear. Get status. Get commit dash am. Camera polish and oh, get add dot. We'll add those. Get commit dash am. This is, I guess the camera polish is not in that other commit. Oh, well. Camera polishing. Camera polishing code is basically what that is. And we also are compiling right now. Like, we're not broken. I mean, there's a lot of stuff we need to add, but we're not broken. So we are going to git push kanji coder master. Right, so if you want to take a look at the code, it's up there. Windows 32 64-bit. If you don't have exactly that, it's not going to work for you. I apologize, but I did a lot of weird things in the code base that are very operating system specific, even bit width specific, because there's like one line of assembly that is used to help me grab the kernel32.dll without using windows.h, and after I've in order to grab kernel32.dll, I have to traverse the pub file, and then once I've grabbed the base address of kernel32.dll, I have to manually traverse the exports table and find load library and get proc address, and I have to do all of this without any header files, without any struct definitions, just by manually traversing offsets, and that's like complete craziness, but that's what I did, so oh well. So let's get out of here, because we're at 420, so blaze it, yeah. How about 420 and 42? Yeah, why not?